Hey all, welcome back to Cracking the FAANG interviews. And if you haven't liked, shared, or subscribed to our channel already, please do so. Today I'm going to be talking about a very important problem. This is a Leetcode medium, and it's been asked a lot at Amazon interviews. Apart from Amazon, I've also seen this asked at Salesforce and Facebook coding interviews. So let's understand the problem. The problem is asking us to find number of times element k is present in a given sorted array. And I'll quickly write an example here. If you're given a sorted array like 1, 2, 2, 5, 6, and I ask you to find number of times 2 is present, it's present 2 times. Let's jump right into the problem. I have a snippet here from Leetcode. I'll also leave a link to the problem in the description if you want to try this out yourself. So the crux is you've been given an array of integers called nums. You're given this target value, or as I like to call it, k, and you essentially have to find the number of times target is found. And if it's not found, the indexes that we are supposed to return are -1 and -1. All right, let's look at an example from Leetcode. This is the given sorted array, and we are asked to find the target 8. 8 is present twice, and in this question, you're going to be returning the index 3 and 4. And here we are asked to find 6, but 6 is not present, so you return indexes -1 and -1. I hope the idea is clear. Now, before I jump to the solution, I quickly want to brainstorm with you and come up with the approach. I think this is very important before you start writing code. So you're given a sorted array and you're asked to find a target. Let's forget that we are asked to find number of times, but if you're ever supposed to find number of times something is present, you have to find that element, right, in the array, like 8 in this case. So it's a search problem, and you're given a sorted array. And in our previous videos, we've discussed this. Whenever you're given something which is sorted, an array which is sorted, or a linked list which is sorted, you can always, and it is a search problem, you can always think of using binary search. So if I were to solve this with my brute force method, I'd just iterate through the array, try to find 8 with the linear method. And just go through the entire array, count how many times I see 8. This would be a linear algorithm often. But with binary search, I can optimize this to O of log n. The reason we can optimize it from O of n to O of log n, what binary search essentially does is it takes a problem and divides it into half of subproblems all the time. You can think of it similar to dynamic programming, but here the size is always half. So if you're given an array of size n, and the next step will make it n by 2, n by 4, 1, and so on. And the time complexity, the total amount of work you do here, is defined by O of log n. I hope the idea is clear. And I'm going to jump straight into the code now, given we have established what method we are going to use, which is binary search. So whenever you're writing binary code for binary search, the first thing I recommend is write standard binary search, or think of standard binary search, and then modify it to your need. So here, if I'm given a sorted array and I'm asked to find number of times this element occurs, how could you do that? You can use the indexes and say, let me find the first index at which this element occurs, and let me find the last index at which the element occurs. And the number of times I can this element occurs can be calculated simply by subtracting start and end index, if you want to calculate that. But in this question, you are just returning start and end index. All right. I hope the idea is clear. Why and how we are gonna apply standard binary search. Now I'm gonna walk you through the code. So the first thing you do with binary search is you set the start index and the end index. You come up with a mid variable. Again, I've initialized it here. You can choose not to and use it directly inside the loop. We wanna we want to run binary search till we are done with the entire array, right? So I have this condition start less than equal to end. Again, this is standard binary search. And here for the first thing you do is you calculate mid. So if I give you a start position, end position, you calculate the mid position by simply adding the two indexes and dividing them by 2, which will point you to the middle of the array. And if you've hit the target, you have two cases. You could either be finding the first index or the last index. If you're finding the first index, I'm defining that with this parameter called mode to the function. So if mode is 1, you're trying to find the first index. If you're at index 0, it's you found the start index already. So you simply break. If not, you move the end to mid -1. So what I mean by that is if you're searching for 2 and your mid is here, you're not you feel you're not at the start index yet, because there's still a way to go. There's a 2 here, so you simply keep your start where it is and you move the end here, because you by now this is not the first index for 2. All right. So similarly, we do the same when mode is 0. We define that as the case when we find the last index. And again, similar condition when you're at the last index, if you're there, you break and you return mid, because this is the last occurrence. This is a sorted array. So you cannot have any rotation or any instance of 2 here, which will be the last index. If not, you just move start to the right side from mid, because now mid, that's not where the last index is, right? So you have room to move the pointer. And if that's not the case, if you haven't hit the target, you simply do plain old binary search. You move to the left if you are at an element which is greater, or right if you're at an element which is less. And there can be a case here, which is a special case, if start becomes greater than end. So what this will tell you is you could not find anything. So when this loop breaks, it hasn't found anything. So the start pointer will cross the end pointer. That means it didn't find anything. It didn't break out of the loop, right? So that tells you didn't find the element, and you simply return -1. So you run this binary search 2 times, one to find start with mode 1, one to find end index with mode 0, and then you return both your indexes. I hope the idea was clear. Please leave a comment down below if you have any questions about the explanation, or if there's any other problem you'd like us to solve for you. Thank you again for watching Cracking the FAANG interviews. Please like, share, subscribe, and also hit the bell icon so you do not miss any of these important interview questions. I'm going to be covering a lot more Amazon and Facebook interview questions in my next videos. Stay tuned for